Now, a counterexample is a broken promise. It preserves the hypotheses but contradicts the conclusion. Now, I'm going to ask you to provide a counterexample of the following statements. Once again, the hypothesis is true, but not the conclusion. So when I see a conditional statement, if a number is divisible by 2, then it is also divisible by 4. In this case, I can see my words if and then. They help me identify the hypotheses and the conclusion. The if part is the hypothesis. The then part is the conclusion. My hypothesis is not always at the beginning. So keep in mind I said the if part is the hypothesis. The then part is the conclusion. When the conclusion happens to be at the beginning of the sentence, we don't start with the word then. But once again, I'm just looking for if and then because that's actually what helps me identify the hypothesis and the conclusion. A counterexample is the hypothesis will be true, but not the conclusion. Because I'm asking for a counterexample, I know there's an example when I can prove the hypothesis to be true, but the conclusion to be false. So a number that is divisible by 2, that's the hypothesis. So I want to think of a number that is divisible by 2. Divisible, once again, means that I explained this in the previous lecture. Divisible by 2 means I'm going to divide a number by 2 and I do not get a decimal. So I want to think of a number that is divisible by 2, but it is not divisible by 4. So I want the hypothesis to be true, but not the conclusion. I could think of many examples. In this case, let me think of the number 6. Right? 6 is divisible by 2. 6 divided by 2 does not give me a decimal, but it is not divisible by 4. All right, 6 divided by 4 gives me a decimal. Or a fraction, however you guys want to see it. All right, now let's take a look at question number 10. If x is an integer, then the square root of x is less than x. I can see my words if and then. My if part is my hypothesis. My then part is my conclusion. For a counterexample, once again, I want the if part, I want the hypothesis to be true, but the conclusion to be false. Once again, I'm not asking for an example when this case is true. An integer is basically a whole number. Remember, whole numbers are like 0, 1, 2, 3, 4, 5, 6, like whole numbers, but integer also includes the negatives. At this point, we don't know how to do the square root of a negative, so I can only think of an integer that is not negative, right? Integer, once again, in this case, I'm thinking of 0, 1, 2, 3, 4, 5, 6, 7, on and on. So I want to think of an integer such that the square root of x is not less than x. So once again, I'm not trying to prove this right. Let me show a wrong example. Somebody come in can say, well, x equals 4. I can think of the number 4. Right? 4 is an integer, and the square root of 4 is less than 4. I just show an example when this is true. But once again, I don't want to do that. I want to think of a value of x such that the square root of x is not less than x. Let me think of the let x equals 1. Right? X equals 1. 1 is an integer, so I'm keeping the if part true. I'm keeping the hypothesis. But when you think of the square root of 1 being less than 1, right? The square root of 1 is 1. 1 is less than 1. See how the conclusion is not true? I just came and thought of a counterexample. Counterexample, once again, is the hypothesis is true, but the conclusion is not. The if part is true, but the then part is not. That's what I think of a counterexample. Now let's think of the question number 11. If a number is squared, then the result is even. I can see my if and my then part. My if part, that's my hypothesis. The then part, that's my conclusion. I'm thinking of a value. I'm thinking of a number that I can square, but my result is not even. Once again, I want the hypothesis to be true, but not the conclusion. I'm going to think of a number 5. Right? 5 squared, right? I can square the number 5. 5 squared is 25, which is not even. Right? I'm keeping the hypothesis true, but not the conclusion. All right, let's think of question number 12. If two numbers are added, then the result is bigger than both numbers. I can see my if and my then words because that helps me identify the hypotheses and the conclusion. The hypothesis is the if part, and the conclusion is the then part. So I want to think of a case when this is false. Remember, in order for this to be false, the hypothesis will be true, but not the conclusion. So I want to think of two numbers that I can add, but the result is bigger than both numbers. So I'm going to think in this case, once again, I'm not looking for a case when it is true. I'm looking for one case when it is false. Let me think of the numbers 5 and -3. If I add these two numbers, I know 5 plus a -3, my answer is 2. 2 is bigger than -3, but 2 is not bigger than 5. Remember, the conclusion here was the result is bigger than both numbers. Right? 2 is not bigger than 5. So I just show one case where the hypothesis is true, but not the conclusion.